Hello everyone, welcome to Helm of Science. So I hope all of you are doing well in this current COVID situation, and I hope that all of you are studying hard. So in this class, we shall discuss some important questions from the chapter Structure of Atom. So let's get started. In the first question, you have to explain why sodium ion, that is Na plus, has completely filled K and L shells. Now we know the electronic configuration of sodium having its atomic number 11 is 2, 8 and 1, right? Now it has been said that it is Na plus ion. So if I write Na plus, that means sodium ion will lose one electron from its outermost shell and it will become 2, 8, right? Now the question is it has completely filled K and L shells. Now this first shell, we know the first shell is K shell and the second shell is L shell. Now from the Bohr-Bury's rule, we can determine the maximum number of electrons that a shell can accommodate. So according to that rule, if I consider K shell, what will be the maximum number of electrons that it can accommodate? We can determine it by the formula 2n square. Now for K shell, the value of n is equal to 1. So 2 into 1 square. That means it is 2. Hence, the K shell is completely filled. We have proved here. Similarly, if I apply it on the L shell, what will I get? For L shell, we know the value of n is 2. So 2 into 2 square. So that will give us 8. So 8 electrons is also present in the L shell. Now we can say that sodium ion, that is Na plus, has completely filled K and L shells as it contains 2 and 8 electrons respectively. Okay. Next we move on to the second question. If Z, that is the atomic number, equal to 3, what would be the valency of that element? Also name the element. Now we know the atomic number of the element, which is 3, it will be lithium, right? We know that, and its symbol is Li. Now if we write down the electronic configuration, we know the first shell can contain 2 electrons, so we have written 2, and the next shell, it will contain only 1 electron. So now we all know every element tries to attain stability by attaining the nearest inert gas configuration. So what will it do? It will tend to lose one electron to become the stable inert gas configuration. That is, it will try to attain the configuration of helium. So we can say that lithium will exist as Li plus electron. That means it will lose or it will release one electron in order to attain the nearest inert gas configuration and become stable. So we can conclude that as lithium loses one electron, that means its valency will be equal to 1. That means the valency of lithium here will be equal to 1. Okay. Next we move on to the third question. Find the number of valence electrons in chloride and oxide ion. Now chloride ion means it will have one negative charge. This is chloride ion. This is chloride ion, right? Next is oxide ion. Oxide ion is represented by O2 minus. This is our oxide ion. Now we have to find the number of valence electrons in these two ions. Now we know Chlorine has an electronic configuration of 2, 8, 7. Now, since the ion is chloride ion with a negative charge means an electron has been added. That means in the outermost shell, one electron will be added. So it will be 2, 8, and 8. And we know valence electrons are those electrons which are present in the outermost shell of an atom. So the outermost shell of chloride ion is this one. And how many electrons are present? 8 electrons. So we can say valence electrons in case of chloride ions is equal to 8. Similarly, if we apply it on oxide ions, at first we have to write down the electronic configuration of oxygen, and that is 2, 6. Now, for oxide ion, the formula or the symbol is O2 minus. That means 2 electrons has been added. That means in the outermost shell, we have to add 2 electrons. So this 6 electron will be 8. Why? Because 2 electrons has been added. Now again, the valence electrons, that is the number of electrons which is present in the outermost shell. For oxygen, this shell is the outermost one and it contains 8 electrons. So we can conclude valence electrons in case of oxide ions is also 8. Understand? Valence electrons basically is the number of electrons which are present in the outermost shell of an atom, of an element. This we have discussed in our class. So I hope you have understood this question. We move on to the fourth one. Write the electronic configuration of oxygen, that is O and O2 minus. So we have done this question just in the third one, that means in the previous one. So I'm again repeating this. Oxygen has an atomic number of 8. So it will have a configuration of 2, 6. So this is the electronic configuration of oxygen. Now if we come to oxide ions, so it will be how much? 2 electrons will be added in the outermost shell. That means this 2, 6 will become 2, 8. Okay, this is the electronic configuration of oxide ions. Question number 5. Write the maximum number of electrons present in L shell. Now we know L shell is the second shell or the second energy level. So for L shell, the value of N is equal to how much? It is 2. And according to Bohr-Bury rule, the maximum number of electrons in L shell will be equal to how much? It will be equal to 2n squared. And for L shell, the value of n is 2. So we will just put the value of n here. 2 into 2 squared. That means 8. 8 electrons. So the maximum number of electrons that can be present in L shell is 8. Okay. You have to find out using Bohr-Bury rule. And it is applicable for all the shells. That is for M shell, for N shell, for K shell. You have to apply this Bohr-Bury rule. Okay. Next is question number 6. If an atom contains one electron and one proton, will it carry any charge or not? We know proton carries positive charge, isn't it? And electron carries negative charge. We all know that. Now, in the question, it is said that if an atom contains one electron and one proton, will it carry any charge or not? So, if an atom, if this is an atom, if an atom contains only one proton and in the surrounding shell it contains only one electron, so what will it do? It will neutralize the positive and negative charge, right? So the atom will be neutral in nature. Why neutral? Because the positive and negative charge will cancel out each other, and as a result, this atom will not carry in charge. Atom will be neutral, that is, it will not it will not carry any charge. That's why we have used this neutral term. Okay, that means the atom will remain neutral if it contains only one electron and one proton. Understood? This is an important question that you have to understand. Next, we move on to question number 7. Write the valency of chlorine, sulfur, sodium. Write the valency rather. So for chlorine, the electronic configuration is 2, 8, 7. So in order to attain the nearest inert gas configuration, what it needs to do? It has to accept one electron to become 2, 8 and 8. Okay. This is the configuration of argon. We all know argon is an inert element and it is extremely stable. So from this we can say that the valency of chlorine will be equal to 1, as it will accept one electron to become stable. Similarly, for sulfur, if we write down the electronic configuration of sulfur, it is 2, 8 and 6. So in order to attain the nearest inert gas configuration, it will require 2 more electrons to become 288, that is to become the configuration of argon. So we can conclude that the valency of sulfur is equal to 2. Similarly, for sodium having atomic number of 11, 11, its electronic configuration is 281. Now what it will do to attain the nearest inert gas configuration, it will release one electron to become 2, 8. That is the configuration of neon. So we can say that as it loses one electron, so it will have the valency of 1. Okay. So for chlorine, it tends to exist in Cl minus form, that is chloride ion. Similarly, for sulfur, it exists in sulfide, that is S2 minus form. Okay, these forms will be extremely stable. And for sodium, as it releases one electron, so it will try to stay in Na plus form, that is sodium ion. This is sodium ion, Na plus. Understood? Next, we move on to question number 8. An atom has 3 shells, out of which the 2 are completely filled and the third shell has 6 electrons. Find the element. So we have been told that the first 2 are completely filled. So we know the first shell is K shell, and the total number of electrons that it can accommodate is what? Equal to 2 electrons. We all know that. The next shell, that is L shell, it is also completely filled. So according to Bohr-Bury rule, we know that the L shell will contain a maximum of 8 electrons in its orbit or in its shell. So I'm writing here 2 and 8 electrons in the L shell. Now in the question it is mentioned that the third shell, is M shell. M shell contains 6 electrons. Okay, 6 electrons. Now we have to find the element. So in order to find the element, we have to add the number of electrons. So 2 plus 8, 10, 10 plus 8, 10 plus 6, 16. So 16 electrons in total. And we know that the number of electrons in an atom is equal to the number of protons. So we can easily say the atomic number or number of protons is equal to 16. And we know for atomic number 16, which element has the atomic number 16? It is sulfur. Sulfur. It is symbolized as S. So by calculating the number of electrons, we have concluded that the element is sulfur. Okay, here the number of electrons is equal to number of protons, and we also know that protons is equal to the atomic number of an element. So as it contains 16 protons, so we can say that the element will have atomic number 16, and finally we come to the conclusion that the element is sulfur. Next is, now this is an important question. What are the valencies of helium, neon, argon? See, helium atomic number is 2. So we know by the rule of duplet, the outermost shell of helium has 2 electrons and it is extremely stable. So it will not tend to lose or gain any electrons in order to attain its stability, right? It is already in its stable state. So it will not tend to lose or gain electron. Lose or gain electrons. It won't tend to lose or gain electrons. Okay. Similarly, for if you see neon, it has the atomic number 10. Okay. So I can write it as 2, 8. So same case will be applicable for neon also, as it has 8 electrons in the outermost shell. So by the rule of octet, it is also extremely stable. And a stable species will never undergo any oxidation or reduction. That means it does not tend to lose or gain electrons in order to enhance or in order to attain its stability, as it is already in a stable state, right? And finally, for argon also, having atomic number 18, it has the electronic configuration of 288. Now, as its outermost shell also contains 8 electrons, so it is also extremely stable. It will neither lose or gain electrons. So we can say that the valency of helium, neon, and argon will be equal to 0. Okay, as they are extremely stable, hence they do not have to undergo any sort of bonding via losing or gaining of electrons. As a result, they have 0 valencies, and hence they are called inert elements, okay, or noble gases. They are extremely stable in nature. Now we come to the last question of today's class. This one is a sort of mathematical calculation. If bromine atom is in the form of 2 isotopes, that is bromine 79, I'm writing here bromine 79 and bromine 81. and their abundance is 49.7% and 50.3% respectively. Its abundance. Abundance means its availability in nature. The availability of bromine 79 is how much? 49.7. And for bromine 81, it is 50.3. Okay. Now you have to find the average atomic mass of bromine atom. Okay. Now, for finding the average atomic mass, what you have to do is average atomic mass, you have to multiply the mass number with their respective abundance, respective natural abundance. Okay. So for bromine 79, I can write 79, that is its mass number multiplied by its natural abundance. This is its natural abundance, and we have to add it with the mass number, that is 81, and multiplied by the natural abundance of bromine 81. Okay. This is 50.3. Okay. 50.3 divided by, as we are doing a percentage here, so we have to divide the whole numerator by 100. And if you solve this, you will get 8000.6 divided by 100. And if you solve it, you will get 80.006. That is almost equal to 80. So this will be your answer, right? So in this way, you have to calculate the average atomic mass. That is, if you are given two isotopes and their natural abundance is also given, you have to just undergo multiplication of their respective mass number and their natural abundance, and then add it with the another isotope, and you have to divide it by 100, and you will get the average atomic mass. So that's all for today's class. I hope all of you have understood the questions. If you have any queries, then do let me know in the comment section. You can drop your questions and your queries there. So I will interact with all of you. So we shall meet in the next class. Until then, try to stay at home, stay safe, and study hard. Thank you so much.